Here's one more method example we're going to look at. To set up the situation, here's a geometry problem. These are all right triangles, and down here, and they're isosceles right as well. So each of the legs are congruent within each triangle. And we're given that this triangle right here has legs of 1 and 1. And based on this structure, we'd like to know how long this hypotenuse is of the last triangle. So to do that, we're going to need to utilize Pythagorean theorem function, which we sort of wrote before, but we're now going to write using returning that we didn't have before. So because this method, I believe, needs to have a result that we don't need to display, we should make this type here double, and then we'll call this the Pythagorean theorem method again. And I believe we need two parameters for the legs. And then what we did before was to get the hypotenuse, we would do the square root of a squared and b squared, and then because that's the answer to what a squared plus b squared, the square root of that is, that's the length of the hypotenuse, we're just going to say that's a result. And then up here in the main method, we could just put in whatever numbers we want. In this case, we'd want them to both be 1 and 1. And if I compiled and ran this, it looks great. And then, oops, nothing appears because remember we need to store this result. And then we can display it if we want to see that it's actually working. And if all is going well, we should see about 1.414. Sounds good to me. It did the Pythagorean theorem exactly right. So we have this nice little method that we could use over and over again if we like, and it can take an input and give us an output. So essentially what we want to be able to do is do this multiple times. So we could do this, double result 2. We could call the Pythagorean theorem method again, and we'll pass in the result of calling the Pythagorean theorem the first time, because this is the hypotenuse of the first triangle, and then that becomes the length of the leg of the second triangle. So if you pass it in, that should give us the hypotenuse of the second triangle. And then, of course, I need to print out my result. Unfortunately, we get an error. And the problem, as it says, is that for the method Pythagorean theorem, it cannot be applied to int. It's requiring int, but it found double. What that means is that the method Pythagorean theorem says it needs two integer values, but here we're trying to put in two double values. And we really do need these to be doubles. So these need to be changed. And now if we compile and run it, we'll find that, interesting enough, the length of the second triangle hypotenuse is 2. Now, we could go with this, but one thing I think would be a good idea, because we're going to do this multiple times, is we don't really need another variable. We can just replace the value in the old variable. And so this expression looks a little complicated, but it essentially says that the old result was the hypotenuse of the first triangle. Now we're going to put in as the legs of the second triangle, and when we store it back into a result, we're going to think of it as the hypotenuse of the second triangle. So this way, when we compile and run it, still gives us the same answer. And now the best reason why we'd want to do this is now we can just copy and paste this line of code multiple times without making any changes. So if I run it now, compile, run, that's 2.82. Now I should go back and count to make sure how many of these we need. So 1 triangle, 2, 3, 4, 5, 6. We need that command 6 times, so I'm up to 3, 4, 5, 6. And this should be our answer. Compile, run. It turns out that the length of the hypotenuse in our question turned out to be 8. Now, eventually we'll learn how to do this repetition without having to copy and paste so much, because this would be annoying if you had to do this 1,000 times for a say. But for right now, this is sufficient to answer a question of, for this setup, what will be the length of the hypotenuse of the last triangle? It'll be 8. We accomplish that by writing a method that would take in two inputs, do a calculation, return it, and we use the result multiple times. So hopefully this example made sense.